Hi guys, this video is to help you understand the first lesson, which is two parts. One is the special angle, which are 30 degrees, 45 degrees, and then 90 degrees. I'm sorry, 60 degrees, and then how to find the trigonometric ratio of an angle that is bigger than 90 degrees. So I will just to summarize it. I'm not gonna explain in detail. I will explain by doing examples. Okay. So for the part one, which is a special angles. And actually the special angles are 0, 30, 45, 60, and then 90 degrees. So these are the angles that have all the specific value to it. And usually it's the exact value. Remember, it's the exact value. I will not accept any of the decimals on the test or the quiz as a part of your solution. Okay. So in this case, you just need to draw two triangles. One triangle is the one that has 45 degrees. So 45 and then 45. Now just need to remember that each side here is 1 and 1, and because of Pythagorean theorem, your hypotenuse becomes square root of 2. Another triangle then is the triangle with 60 degrees and then 30 degrees. Now obviously you can use a sine cosine depending on which angle you're looking at, right? So then in this case, your hypotenuse is 2. Your short side, which is the opposite side of the 30 degrees, remember the smaller angle gives a smaller side length. So that is 1. And then 60 degrees gives me square root of 3. And this is all because of the Pythagorean theorem. Now then, according to our sine, cosine, and tangent, basically we can simply just find them, right? So for example, in this case, what is my sine 45 degrees? In terms of the exact value, then it becomes the opposite over hypotenuse. So it is going to be 1 over square root of 2. On the video, I also said this 1 over square root of 2 is the same as 2 square root of 2 over 2. And that is because we can rationalize this, right, by multiplying the top and the bottom by square root of 2. So this then becomes square root of 2 over 2. So sine 45 degrees is either of. Okay, you can actually give me either of the answers. I usually prefer this because there's a pattern to it that I actually can show it to you probably in the class. Another example can be what is then a tangent 30 degrees, right? So tangent 30 degrees, that means we're looking at this 30 degrees. So this is my opposite side and this is my adjacent side. So tangent 30 is then opposite over adjacent, so that will be 1 over square root of 3. If you want to rationalize this one, then you basically multiply square root of 3 to the top and the bottom. So then this becomes a square root of 3 over 3. But again, I don't mind either of the answers. Okay, so that was the part one. So you really do need to remember this. You really need to remember these two triangles. There's a chart that I can show it to you in class, but we'll see what happens to it. And some of you may ask me, what about the sine 0? What about the sine or cosine 0? Well, that's basically a flat line, isn't it? So, for example, the 0 means it's just a flat line. There is no opposite to it. There is no opposite length to it. So you can simply just consider that it's a kind of shape that has a 0 degrees. And because of that, you have the opposite length of 0. And then based on that, you can calculate that. Then what is my base length? Keep the base length as 1. Okay, and then you will be able to do it quite simply and then easily. Now, then the part two. Now, then the part two becomes how to find the trigonometric ratio of an angle that is greater than 90 degrees. So when you are doing this, make sure that we have to look at the related acute angle or reference angle. Okay, so I will probably interchangeably use related acute angle, or I use reference angle. The textbook uses reference angle, but most of the time I use related acute angle. They're the same thing anyway. So the related acute angle or the reference angle is the angle between the terminal arm and your x-axis. So this is your, let's say, related acute angle or reference angle, or this could be your reference angle, depending on where your terminal arm is located. So then in this case, if I have a terminal arm located in the third quadrant, remember it is first, second, third, and then fourth quadrant, right? So if the terminal arm is located in the third quadrant, that means it turned and rotated all the way from the initial arm, which is the x-axis, the positive section of the x-axis, to this terminal arm, and that is my principal angle. So the actual angle that you rotate is called the principal angle. The angle between your terminal arm, the x-axis, is the reference angle. And when you're looking for a trigonometric ratio of an angle that is greater than 90 degrees, we use the reference angle quite a lot of times. So for example, if I say you are supposed to look for cosine 225 degrees. If I, what is this thing? Then what we need to do is first we need to locate where the angle is by drawing the terminal arm. So from here to the other side, that's 180 degrees. And then we know that from 180 to the next axis, that is 270. So we know that the cosine, so we know that the 225 is located in the third quadrant. Now we know that from here to this line is 180 degrees. Therefore, in order for us to make 225 from 180, we know that this reference angle is 45 degrees. Okay, so that is the first thing. So the first, you have to locate where the angle is. You have to find what the related reference angle is. And then second step is then to find what sine it's going to be. So in this case, hopefully remember the Kest rule that I showed you how to develop it. So the Kest rule actually has CAST, and each letter indicates that the trigonometric ratio that is associated with each letter is the only one that's positive in that quadrant. So for example, C is associated with cosine, or if that's the letter that cosine starts with. So cosine is the only positive in the fourth quadrant, whereas sine is the only one that's positive in the second quadrant. Then what is A? Well, A is basically all. So if you want to use it as a C, that's okay. Then we can kind of call it as CEST rule, probably. Completely up to you. I just use A since it's all. Okay, so A means that everything is positive in the first quadrant. So in this case, the angle is in the third quadrant, so it has a T, it's in the T zone. That means the tangent is negative. So tangent is positive, rest is negative. Therefore, my cosine 225 will have the negative sign since it's in a T zone instead of a C zone. And then it will still have the cosine. Then we look at what the reference angle is, which is then 45 degrees. Now, we know what the cosine 45 degrees from the special angle. So from this, we have then cosine 45 degrees as a 1 over square root of 2. So cosine 225 is then negative 1 over square root of 2. So this is basically the summary of how to do these. Okay, so let's actually do one more example so you actually will be able to try it. So then here, let's say I'm looking for a tangent. Sure. Let's say it is then 300 and sorry, not 300. Let's say it is 390 degrees. Okay, so then we have to relocate where that 390 degrees is. Now remember that one cycle or one rotation, one full rotation is 360 degrees. So that means we have to go a little further to get to the 390 from 360, which is then 30 degrees. Obviously, then you're going to ask me, or you may ask me, why is it not in this quadrant? Well, that's because if you have your terminal arm rotated this much, this is way over 390, isn't it? Because from here to here is 360, and then from here to here is 90. So that basically means that you're going into the 450 degrees or over that zone. So we cannot have our terminal arm in the second quadrant. Our terminal arm then should be in the first quadrant. So 360 degrees of rotation, and then we have to go a little further, and that's our 30 degrees because that makes our principal angle of 390. So in this case, according to our test rule, so the first step is done. Now then we know that the tangent 390 is equal to, now all means all is positive, so it will be just a positive tangent, and then the reference angle is 30, so it will be 30. Using your special angles, tangent 30 is 1 over square root of 3. Or you can say this is square root of 3 over 3. It's completely up to you. Okay. So hopefully this helps you. Then the last example was that if you have if you let's say you're a lifeguard, so it's a word problem. So let's say if you're a lifeguard and there are two boats from you. So one boat is, let's say, due this time east, sure, due east 20 kilometers. So this is due east. And then that's our person A. Then our person B, or the boat B, is at sure 60 degrees west from, or west of north. So 60 degrees west of north means from north you go west to 60 degrees. So it will be all the way to there, isn't it? So then, do we really care about this angle when we're measuring it? Not really. We actually do need the reference angle, and then we know that the reference angle in this case will be 30 degrees, whereas our principal angle will be overall, which in this case gives me 90 plus a 60, that is what, 150 degrees, right? So then if I ask you to find the angle of separation, so then angle of separation means the principal angle, isn't it? It's the angle that's in between the person A and the person B, or the boat A and the boat B. So angle of separation, then is basically 150 degrees. That's 90 degrees plus a 60 degrees, right? Um, then I say, what is the trigonometric ratio of this 150? So then I'm going to ask you, what is sine 150, cosine 150, and then tangent 150? Well, if you look at it, sine is positive in the second quadrant, so it will be positive for the sine, but our reference angle is 30, so it will be just a sine 30. Whereas the cosine is negative in the second quadrant, which is S zone, so that will be negative cosine 30. And then lastly, the tangent is also negative in that, so it will be negative tangent 30. And then rest is quite simple because the 30 degrees is one of our special angles. So according to our special triangle, sine 30 degrees should be 1 over 2, and then negative cosine 30 degrees should be negative square root of 3 over 2, and then the negative tangent 30 degrees will be negative 1 over square root of 3. Okay, so that's how we can find it. Now, one last thing before I finish the video. Well, it's already 13 minutes long. Make sure all the answers are in exact value. Okay, I cannot emphasize this more. So make sure everything is in exact value, meaning it's either in a whole number fractions or radicals. Okay, so that means, or whole numbers, obviously, right? So it means no decimal. Okay, there is no decimal in your answer. If you do put your answer in decimal form, unless it is instructed to do so in the question, then you are going to lose your mark. Okay, so be really careful with it. So hopefully this helps you. Okay, bye guys.